Hi guys, Sam here. So basically, I was trying to 3D print this part, and it obviously failed. And the reason it failed was because the Ender 3's feed arm in the extruder cracked. And when it cracked, it basically stopped extruding plastic. No extruded plastic means no part. So this is not uncommon for Creality printers. For the Ender 3, this is already a 3D printed replacement arm for the original arm that cracked. And in general, it's just a common problem with the feeder that's included. So I decided to go ahead and 3D print a new feeder. The feeder I'm going to print is called the Bantam feeder. You can find it online for free. And I wanted to give it a shot since it looks like a pretty solid design. So in this video, I'm going to go ahead and show you guys how to print it out of PETG, how to install it on your printer, and then we're going to take a look at what kind of a difference it actually makes. Do the parts actually improve or do they not? So without further ado, let's get printing. Last night I actually went ahead and 3D printed the Bantam feeder, just like the one that you'll get from the website that's in the description. So I printed off the feeder body, which looks like this. You know, all the holes look good, everything's looking good. Then I went ahead and I printed the armature, and I also printed the base plate. So these are the three parts you need. Now for the Ender 3, you're going to want to make sure that this is the 13mm bearing. Okay, that's very important. Okay, so now those are those parts. Now in addition to this, I also had to run to Ace Hardware and actually buy a set of screws and nuts. So the first of these was I bought 4 M3 20mm screws. So they should look something like so. So we have the 4 of these. These are used to actually screw into the 4 holes, and they attach it to the stepper motor and to the plate on your Ender 3. Now, I also bought 2 M3 nuts. Okay, so that's these two guys here. So you'll have to have 2 of those. And this is used in the spring tensioner assembly, which goes through this hole in here, and that's where the spring will go. I also bought 1 M3 8mm bolt. So it looks like this. And then I bought 1 M4 washer. Okay, that's this guy here. All right, and finally 1 M4 12mm screw, which looks like this, and finally 1 M4 nut. Okay, so these two are on the armature, and the rest of these are on the body. Okay, so these are the parts that you actually need. So now that we have everything we need, we're going to go ahead and take the old feeder assembly off of the printer, and we're going to install this new one on there. Yeah, let's go ahead and take off this old assembly. So we have all the hex keys that came with the printer. That's all we're going to need. So first we're going to just take off all the parts. Okay. And this is pretty self-explanatory. But before we take them off, we actually want to remove the old filament from the printer. So we're going to go ahead and set the temperature to 240 degrees Celsius. Okay. So make sure you roll up the filament really well and don't let it crisscross itself. Alright. There we go. So now we have the filament off, and now we can go ahead and begin taking the printer apart. So first we're just going to remove the armature. There we go, armature's off. Okay. Now that we have the armature off, we need to take the rest of these parts off. So we're going to unscrew the Bowden tube. Okay, so the Bowden tube is off. So now we need a smaller wrench. So we're going to use this one. Additionally, notice that this is held in place, that the stepper motor is held on by these screws. So okay, you'll want to be careful now not to drop the stepper off. It's going to come off at the same time. So put your hand underneath the stepper Okay, now you see the whole thing comes apart, and now we unplug the stepper, and there we go. So now we're ready to go ahead and begin mounting. So that's what it should look like. There should be nothing here. It should be empty. Okay. So alright, so now that we have the spring off, we actually have to go ahead and put the new, we're going to reuse the pulley from the Ender 3. So for that we're going to need to just unscrew it using the Allen keys that we have from the printer. Everything on this printer should be removable with the Allen keys given with the printer. So this is the temporary arm, so I'm just going to go ahead and unbolt it from its from the temporary arm I have it in. There we go. Which it performed pretty well. Actually, the print looks pretty good with this temporary arm, but I know that this will crack in time, which is why I'm replacing it now. Now, for this part, this has actually a nice feature. Since I'm not screwing into plastic, I'm actually going to screw into a bolt. So we're going to assemble the armature now. So for this, I'm first going to have to break the little filaments that were inside of the hole. So just stick that through. Okay, now I do have a little washer, which I'm wondering if it will fit on here. Oh, it does. So I have a little spring load here. So I think we should go ahead and use that just like it was on the original. Yours will come with that. Then you want to go ahead and slip the bolt through there. Then we want to take the armature, take the M4 bolt, stick it into the hole. It should fit perfectly. If it does not, something happened to your print and it's not printing well. Then we're going to want to go ahead and just stick this guy in here. Now, my feeling is that whenever this was designed, it's pretty exact. So first we're going to have to cut the threads through with the key. So we're going to just go ahead and just screw this in slowly, trying to keep it straight as possible. The nice thing is, since this screws into a nut, we don't have to worry about misaligning the threads now. So we just go ahead, screw it into place. Okay, everything looks good. Now we're going to go ahead and unscrew it real quick. Just like that. Back it out until it's out of the back end of there. And now we can slip the bolt into place. Okay, then just hold the bolt with your finger and tighten the rest of the way with the wrench. Okay, there we go. Perfect. Okay, now this should spin freely, and you can see it does. It's spinning nicely. So that's the first part of the assembly. Now this part will go right here. See, and it fits perfectly. The whole assembly can slide in and out. Make sure that this is not binding. It shouldn't be able to fall if it's stood up, but it should also not take any effort to move. If you have any issue there, this is not going to work. You're going to have to reprint it or sand it. Now we're going to make the spring loading assembly. So for that, there's a little slot here for the nut. So that nut is going to just fall right in there. And the way that this works is that you are going to place you're going to take your 8mm and you're going to put the washer on it. Okay, just like this. Alright, there's the washer and the 8mm. And now you're going to take one of those bolts and you're going to just thread it on to hold the washer in place. Okay, just like this. Alright. Just like that. Okay, and then you're going to want to find a key that will fit it. 2mm key here, and then just get that nice and snug. And you also want to center this as much as possible because the spring is going to push against this, so you want it to be fairly centered. So that looks pretty good to me. It doesn't have to be exact. Okay, let's tighten it up, and then nicely enough we have the wrench that came with the printer. Also we have a little wrench, and that wrench will go ahead and we'll put it onto there. Okay, you see how it looks. Okay, and then we're going to just go ahead and tighten that up until it's reasonably tight, because you don't want this thing to start backing out while you're printing. Okay, there we go. So pretty nice, pretty tight. Okay, good. So now then this part is going to go ahead and we're just going to screw it in to this hole here. Right, there we go. Use the little key again and screw it in. Alright, so now let's screw it all the way in so that way we can have an easier time putting the spring in. Now the spring that is originally there is a little bit too big and stiff, okay? So what you're going to want to use is you're going to want to use a bed leveling spring. If you have not upgraded your bed springs, I highly recommend upgrading to these relatively cheap UXL yellow springs. They're much stiffer. Besides looking fantastic, they're much stiffer. So what this means is that whenever you print, the print bed is less likely to drift around from, you know, removing a print or something like that. So I highly recommend those, and it leaves you with this spring. If not, just to use a spring of the same diameter as your bed spring that you can get at Ace. Okay, now we're going to put that on there, and we're going to go ahead and put this assembly on here. Okay, so see, this cannot back out any further because of this. All right, so the spring is going to pull it forward as far as possible. So now we just have to slide the spring in. Oops. This is the old spring. We're going to put that over there. Okay, and then we're going to just put it into this hole here. See? Just like that. And then we're going to stick it in to this hole here. You see? Oops, not far enough. Put it a little bit further in. And you're going to want to just push it in like that. There we go. See? Beautiful. So this is a very nice thing because all the forces involved are on tension and on pressure here, so basic, and on a nut, and so this is much stronger than the original, these armatures, because all the pressure in the original armature was here, or on in the very original. You can actually see here, you see how it already cracked. So basically all the pressure is in this very thin piece of plastic, and it's along layer lines, and so you're very likely to have cracks happen, and that happened in the original. This, on the other hand, is tension. The other nice thing is that you can actually adjust the tension by sticking a wrench in here and then loosening this, which will increase or decrease the tension on your filament. So the more it's pushed in, the less it's going to be, the more tight it's going to be here, right? So basically that's how you can adjust the tension of this. Now we're going to take this part and we're going to put this here like this. So now once we have this, now it's time to go back to the printer and just bolt this in place on the printer. Alright guys, so basically, I forgot to show you while we were at the table, but basically you're going to want to have a Bowden coupler, and this assembly is going to go on like this. So you're going to want to put that Bowden coupler and screw it in here. It'll be pretty tough at first because you have to screw it in. Try to make sure it's straight. You should be able to see all the way through the assembly once you push this out of the way. Alright, so I mounted it on. And it turns out that when I mounted it, the tensioning spring, which is here, has a big problem. You see, whenever you would loosen it to make the spring tighter, because I didn't have enough tension, the bolt that was underneath it to hold the washer in place actually would unscrew also due to the pressure. So I basically need a lock nut here. I don't have any lock nuts, so what I'm going to do is I'm going to just put super glue on the shaft and then glue the bolt into place. That should solve that problem. So this is the only problem I found with this thing so far, is that in order to service any part of it, you have to take the entire assembly apart, which is a bit of a pain. Alright, so let's go ahead and super glue it now. Alright, so now after a healthy dose of super glue, I'm going to go ahead and let that dry up. And that should be good. Make sure you don't get it on the threads in the front though, because if you do, it will become very difficult to thread into the assembly. So we're going to let that dry now. Now while that's drying, we're going to go ahead and resolve another design defect I found with this assembly, namely that this is clamping by screwing onto the stepper motor, so this does not need to be threaded, and it being threaded makes it much more difficult to install. So I'm going to go ahead and drill out those holes a little bit just to make them the right diameter to where these pieces will slide in and out, where these bolts will slide in and out easily, so that way we don't have to deal with the fact that they're threaded both on the end and also in the middle, because that makes it very annoying to deal with. So we'll do that now. Alright, so now that we've got all the bolts out, we're going to find a good sized drill. That's a little bit too small. That might be exactly the right size there, and then this will be just a little bit larger. So we're going to want to use a 7/64 drill bit. Get the drill out. Alright, we're also going to need a stamp. Just use a filament roll. And let's go ahead and do it. Alright, now that we've drilled the holes out, the bolts will hopefully slide right in. Looks like this drill bit is too close to the size of the bolts. We'll go one size up. Alright, now as you can see, the bolts go in and out, so this will make installation so much easier now. So we're going to want, though in the end you want to use a 1/8 of an inch diameter drill bit to get this effect. Alright, so now we're ready to go ahead and install once the bolt is finished drying, which will give it a bit of time to do that. Alright, luckily for you guys, because the previous time my camera overheated and didn't film the installation, now I can show you guys how the installation is done. So we've just super glued the nuts in place and drilled out the holes to make the installation much faster and much easier. So for the installation, what we're going to do is we're just going to go ahead and put the 4 screws in place, just like so, and then we're going to slide the bottom plate on top of it. With this, you see how it has a slight divot, so you want to flip it so that it slides on just over those 4 screws. You just have to be, so it's probably easier to flip it like this. Okay, like that. Then go ahead and just slide those 4 screws in. So you should end up with something roughly looking like that. Okay, now we're going to go ahead and position it like so. So this button should be facing out. Okay, now we take the stepper motor, plug out, and we just stick it underneath. Okay, then you use the Allen key to just tighten it in place. Okay, like I said, it's going to be easiest if you tighten up one. Make sure you don't make it too tight, because then the other ones will not be able to align. So just enough that it grabs the stepper motor. Okay, so this one has grabbed, so now it's grabbed on, so we tighten it a few turns so it doesn't pop out. And now the easiest one I found is this one, because you can still see it. And then just go ahead and push it through the hole. So there we go. And now you should be able to feel when it goes into the stepper. Okay, so that one feels pretty good. And we're just going to go ahead and tighten it into place a little bit. Looking pretty good. Now let's test the mechanism. So to tighten it, you just stick the wrench through and loosen that bolt. Excellent. So now it's actually doing its job with the super glue. So we're able to increase and decrease the tension now. So we'll start out at lower tension, and then increase tension when we actually start printing. But this is working beautifully now. Okay, overall it looks pretty good. I think we're ready to go ahead and reassemble it, so we'll just put it back down and then just insert our Bowden coupler. Okay, and here we go. So now we have everything set up. All we have to do is move this back here and tighten it back up. And that's the completed assembly. So here's how it looks. And to insert in, and then you tighten it here. So it looks pretty good. I really like the design in terms of this is under tension rather than being in bending, so it's less likely to break, and this whole assembly is built pretty tough, so I'm not worried about it wearing out or breaking. Also, anything under pressure is metal to metal rather than plastic. So overall, very nice design. I really like the way it looks. It looks like a commercial level product, so pretty nice. Alright, so to test out the new feed system, let's print a torture test for the retraction and feeder system. So I've printed this in the past with the old feeder, and the result was a beautiful Eiffel Tower. As you can see here, it came out pretty great. Very little stringing. So we're going to try to print that now with the new feeder and see if we can beat the performance of the old feeder. So let's do it. Really brutal print on the retraction. See, it has to retract every few seconds because it's printing really tiny filament. Test print finished. The Eiffel Tower turned out very good, actually even better than the old feeder was ever able to do, so it's pretty impressive. I saw no signs of slip at all, and actually the retraction is far more precise than I ever saw with the stock feeder. So to summarize everything, this Bantam feeder, it has a lot of good things about it. One, it's very easy to load and unload filament compared to the original feeder. It's very sturdy, so I don't foresee any more cracking problems or issues like that due to the way it's designed, and the adjustable tension works very well. Originally when I printed another one of these, there was some slip because it was actually too tight. That said, this feeder does have a couple of issues. So for one, as you saw, the installation is a little bit involved because you have to drill out the holes, you have to have lock nuts for the tensioner, etc. But probably the biggest thing is that it's a pain in the neck to actually install onto the printer. And additionally, any service to the Bantam feeder, so for example changing a gear or even thoroughly cleaning it, requires disassembling the entire feeder, which is the biggest drawback of this design. But overall, I'd say it's a fantastic feeder, and I'm very impressed with the quality of something that I assembled for around $3 or $4 that it's printed, and that uses almost all stock parts from the printer. So overall, I highly recommend it, and it's able to do a great job. At some point, I hope to test it with flexibles. Anyway, that's it for this video, which is extremely long, so have a great night.